Let's take a look at another example. In this example, we like to calculate the average normal stress in bar BD. Okay, and so in this concept, the stress equal to magnitude of the F divided by the cross-sectional area A. And from the dimensions, we know the vertical length, and so that means the cross-sectional area B is given. So from here, we are able to determine the A. So now the other rigors will be go to determine what is the F. What is the F in this bar BD here? And to determine this one, our hint is to take the free body diagram of this bar here. Let me draw that one here. So this bar is A, B, C. Okay, and take the free body diagrams for here A, we have the loading which is applied 23 kilonewtons. And for B here, that is where the pin is, and you can assume the directions. And say here I assume the direction is downward, and here I assume the direction is downward. And say let me call this is FBD, and this called the FCE. Okay. If you like to assume the direction upwards, it's okay. So which means your free body diagram could be like this. So that is the given loading 23. And if you like, you can also assume the FBD is in this, or FCE is in this way. Okay, and either case will be fine, but keep your calculation consistent throughout the remaining process. So we pick this one, then from here, what happened? So from here we take the, here we have two unknowns, so we need two equations. Here that is everything is in static equilibrium. So the two equations coming from the first one is, for example, we take the moment about the pin C and equal to 0. So here if I take counterclockwise as a positive, so from here you can see here is the distance is 0.4, the distance is 0.26 here. Okay, so in this one the calculations will be 0.04 times FBD. So that is this force, the moment from this force to this, and minus the 0.26 plus 0.4, and that multiply with 23, and that is the contribution of this force to that moment here. Okay, this one equal to 0. And so from here you should be able to determine the FBD equal to 32.5 and unit in kilonewton, because this one is in kilonewtons. Okay, and in a similar way, if we take the moment about the point B equal to 0, so here you can figure out the formulations. So from here we can find out the FCE equal to minus 12.5 kilonewtons. Okay, so under these situations, let me redraw this one. So our free body diagram we took is, this is given 23, and this we calculated FBD 32.5, and FCE we calculated is negative 12.5, and we assume the direction downward negative, so here is upward positive 25. Okay, so here because we calculate this number is negative, with this assumed direction. So here I changed that one. Okay. So now we convert it. And now, respect to this free body diagram, let me take this free body diagram here. So that free body diagram is here. Okay, so that is BD. And this free body diagram is here. So that is the CE. Okay, so in the three free body diagrams, and at the same point, so this is the pin B. Okay, this point are the pin B. They simply locate at the different free body diagram. So to the same point, this is the action reaction. So at this point, that's the action downward. So at this same point in the different free body diagram, that is the reaction. So that is opposite direction with the same magnitude. The same thing here. This is pin C here. Here the same point. In this free body diagram is upward. Okay, action reaction. So that is downward. The magnitude 12.5 here. So from here you can see basically if we want to determine the stress in BD. So here the F equal to 32.5 times 10 to the 3 Newton. And from here you can see BD again. By force equilibrium, you can expect this force here should be 32.5 kilonewton. So in this case, the BD here is under tension. Okay, so using these equations and we implement this equation, sigma BD will be equal to 32.5 times 3 Newton, and the area equal to the area is for here we want to find the maximum value, okay, of the stress. So here the maximum value, let me see if I can erase these things here. Good. So we want to find the maximum value of the stress in link BD. So that is in this smallest cross section and where the pin located. Okay, so that is this is the rectangular cross section, and where that is a hole we drilled to house the pin. So the area, the minimum area is here. Okay, so that one should be equal to 0.008 multiply with 0.036 and minus the diameter of the pin. So that is in meter square. Okay, plug in here, so you should be able to determine that is 101.56 MPa. So that is the answer.